All right, AP Stats, today we're going to look at the one sample mean T interval. Notice that is a T and not a Z, and we'll learn about that right now in this video. So, first you collect ACT scores from a random sample of 25 LHS seniors. So N is going to be 25. From your sample, you find an average ACT score of X bar equals 22.5 and a standard deviation of S equals 2.5. You were told that the population of ACT scores of LHS seniors roughly follows a normal distribution. Find the 95% confidence interval for the mean mu score of the population of all Lindbergh seniors. Okay, so if you remember for proportions, we had P hat plus or minus Z star times our standard error. So we're going to follow the same process for X bar. So this is going to be X bar plus or minus. Like I said, we're not using Z's this time. We're using T's, which will be new for us. And then the standard deviation, which is S over square root N. So it's going to follow a lot of the same processes. Okay, let's talk about this T distribution first. Notice this T distribution looks a whole lot like a Z distribution. It looks normal. Okay, so find this on your pink sheet. This is a copy of it so you can see what this looks like. So to do a T distribution, we need N minus 1 degrees of freedom. So if you remember, N was 25, so N minus 1 equals 24. So if you look closely here, this is N equals 20, or N minus 1 equals 24, degrees of freedom. See that DF right there? That's degrees of freedom. And then what's our tail probability going to be? So we know we want 95%, which means the outside is a total of 2.5% and 2.5%, which you will see here at 0.025. So we take our tail probability, we take our 24, and we match them up right there at 2.064. That's our T star. That's how you use that table. It's actually even easier than using the Z table. So that's pretty easy to do. Okay, so next slide. There's your formula. And we find T star using our N minus 1 degrees of freedom. That's a key point there. So N minus 1 is your degrees of freedom. So you need to make sure that you do that. And then here's the process that we go through. Okay, so you're going to call it a one sample mean T interval. And we are going to define our parameter, which is mu. And so this is always going to say mu equals population mean ... whatever it is. Conditions. First one is the same as with proportions. Needs to be a simple random sample. 2, the sampling distribution is approximately normal because either the population is normal or N is bigger than 15 from the central limit theorem. That is new. That's because we're using T, and so 15 is just big enough. Remember we talked about it just needs to be big enough. Or the data is roughly normal, and then the population is at least 10 times the sample size. There's your formula. There's your same sentence. So there's not too much different here except the name, what you're defining, and the end of number 2, and then the calculations. But it is really, really similar. Okay, so let's actually do the problem we were just working on. Okay, so we're going to do the ACT scores. So we're going to call this a one sample mean T interval. So we want to title it correctly. It's the one sample mean T interval. And then we're going to define our parameter, which is mu, which always starts out with the population mean, and then go back to the question if you need to. So if we go back to the question here, oh, wrong one. Population mean score of the ACT of all LHS seniors. So you can go ahead and write that into your own words. So population mean ACT score of all LHS seniors. Then we have our conditions. We have 3 conditions that must be met in order to complete this interval. The first is a simple random sample. And we are told that the seniors came from an SRS. So on number 1, we are going to say we are given that the seniors came from an SRS. And then number 2, the sampling distribution is approximately normal because, always write that down and then you can finish the rest. The sampling distribution is approximately normal because. Now in this, you could actually say 2 different scenarios where you're told that the population is normal and you also have an n bigger than or equal to 15. Either one is okay. So I'm going to go ahead and write because n is greater than or equal to 15, but I have to write it in context. So I'm going to make sure that you know that my n was 25. And how do I know that this is okay? Because of the central limit theorem. All of these pieces must be intact for that condition to be correct. And then the third is that the population of all seniors is at least 10 times 25 or 250. So we have again the population of all seniors is at least 10 times 25 or 250. Okay, now we can actually get started by finding our interval. So I'm going to spice it up with some new colors here. And our equation is x bar plus or minus t star times the standard deviation, or the standard error, s over square root of n. So our x bar was 22.5, that's what we found in our sample, plus or minus t star of 2.064, that's what we found off the table, times s, which was 2.5, over the square root of n, which is 25. You're going to type that in your calculator, and you end up with an interval of 21.5 to 23.5. There is your interval. Okay, now we need a good sentence to go along with that, a good conclusion sentence here. And that always starts out the same. We are 95% confident, or I am 95% confident, that the true population mean ACT score, we are 95% confident that the true population mean ACT score of all LHS seniors lies between 21.5 and 23.5. And usually we put units on there, but there's not really a unit for ACT, so we're going to go ahead and put a period and end it right there. So that is an example of a one sample mean t interval. So now what I want you to do is go into the homework part and do number 4. Complete number 4, not number 3, skip number 3. You should have already done 1 and 2. Now you're going to complete number 4, which starts out with a medical study of some sort. So go ahead and do that problem and bring that with you when you come in to class. Have a great day.